Riders on the storm. Riders on the storm.
Hello dear followers, today's topic is feeling of NAVLOG and designing of navigation map. To get started, we need to take a navigation map and draw a planned road on it. Let's take a simple road consisting of 3 waypoints. Our first waypoint is Borodianka. Our next waypoint it is Aerodomishel. And our destination it is Airfield Jitoma. Let's connect all our waypoints. Okay, so you can see drone road on the map without top of climb and top of descent. Let's start filling of NAVLOG. The first column it is our waypoints. The first point is Borodianka. Borodianka. The next point is top of climb. The next point is Radomishel. The next point is top of descent. And our destination it is Jitoma. Next column is not applied in our case because we're not using war beacon in our road. Next column it is courses. Courses are counting very simple by such device. The north will be 0 degrees and all other counting by this device. So let's count our courses. The course from Borodianka to top of climb and to Radomishel will be 250 degrees. The course from Radomishel to Jitoma will be 230 degrees. The next our column is altitude. From the top of climb to Radomishel and from Radomishel to top of descent, our altitude will be 4,000 feet, which we chose. The altitude from Borodianka to top of climb will be half of our cruise altitude, it will be 2,000 feet. From the top of descent to Jitoma, it will be the same. It is also necessary to calculate top of climb and top of descent. Top of climb is calculated transition from the climb phase of flight. The point at which the planned climb to cruise altitude is completed. We know that the elevation of Aerodrome Borodianka is 150 meters. It will be 492 feet above sea level. This will be our sea level. Okay. This will be our aerodrome. This will be our aerodrome. And this height will be 492 feet. Stop. The selected altitude for cruise flight will be 4,000 feet. According to the gamut forecast, which I will show at the screen, the temperature at the altitude 300 meters will be temperature 300 meters will be 0 degrees. Temperature at 600 meters will be 1 degrees. And temperature at altitude 1,500 meters will be -6 degrees. I will left the link for the garment at the description of this video, where we can check gamut. And 4,000 feet, it is will be 1,218 meters, and the temperature it is unknown. According to this, I will count the temperature at this height. It will be -4 degrees. The altitude from the aerodrome level to the cruise altitude will be 3,508 feet. If we look at the flight manual of aircraft, in our case it will be Cessna 172, we will find table of calculations of climbing performance. According to this table, we can calculate distance, time and fuel for the reaching top of climb. This is our top of climb.
Okay, this is table of calculations of climbing performance. Using that, we can calculate top of climb. The height which we should reach 3,508 feet. It is approximately 3,500 feet. It is between 4,000 and 3,000 feet. Distance will be for reaching this altitude between 6 and 8 nautical miles. It will be 7 nautical miles. The fuel will used for reaching this point will be between 1.2 gallons and 1.5 gallons. It will be 1.3 gallons. And the time will be 5.5 minutes. Also, we have notes. The note number 1, it is to add 1.4 gallon of fuel for engine start, taxing and taking off. Note number 2, mixture leaned above 3,000 feet for maximum RPM. Note number 3, increase time, fuel and distance by 10% for each 10 degrees above the standard temperature. Temperature is below standard, so we not should to increase time, fuel and distance. Note number 4, distance showed are based on zero wind. Also, by this table, we can find our climb indicated speed. It will be 73 knots. By the calculator ES6B, link I will left it with description for this video, we can calculate true airspeed. It will be 74 knots.
Top of descent is the point for aircraft to begin the descent. At this point, aircraft exits the cruise phase over flight and begins the descent phase to approach altitude. For approximate calculation for standard 3-degree glide path, pilots have adopted a formula to ensure a slow and comfortable descent for their passenger. The rule of 3, it is free descent rule. This rule means for every 1,000 feet of the height, we need to fly 3 miles horizontal flight. The rule of 3 is used both by pilots of small aircrafts and pilots of airliners. In our case, it is necessary to descend from the altitude 4,000 feet. 4,000 feet. To the aerodrome elevation. In our case, elevation of aerodrome UK Zhytomyr, it is 722 feet. Yes, 1 minute. Above sea level, this is elevation. knots. The altitude to descend, this altitude will be 3,278 feet. So, by the rule of 3, it will be 9.8 miles for descent.
The 5 column is column of temperature and speed, velocity and direction. We can look speed and temperature, speed, direction, wind and temperature at the gamut. The link I will show at the description of this video. You can see gamut at the screen of your phone, computer now. So, using this gamut forecast, we know that easter of 31 degrees of east longitude at an altitude of 600 meters, the wind velocity is 20 kilometers per hour and direction 220 degrees. At an altitude 1,500 feet, the direction 240 and the velocity the same 20 knots. We have altitude 2,000 feet, this is approximately 609 meters. So the wind at this altitude 2,000 feet it is approximately 609 meters, will be 220 degrees, the direction, and the speed is 20 kilometers, it is approximately 11 knots. And the temperature will be -1. Also, there will be the same condition, because this position is also east the 31 degrees longitude. At the altitude 4,000 feet, we can also find direction and speed of wind.
The altitude is 1,500 meters. The wind direction will be 240 degrees and the speed will be 2 kilometers per hour. At the altitude 4,000 feet, which is equal to approximately equal to the altitude 1,200 meters, we have unknown direction and unknown speed. At the altitude 600 meters, we have the direction 220, 20 kilometers per hour. So, at x with x will be, the speed is equal as at 600 meters as at 1,500 meters. So, the speed at the altitude 4,000 feet will be the same, 20 kilometers per hour. The direction at the altitude 1,500 feet 240, at the altitude 600 meters 220. So at this altitude at 1,200 meters, the wind's direction will be 2, 3, 4 degrees. So 20 kilometers per hour it will be 230 degrees, and in knots it will be 11 knots. By the same principle, we can find temperature. The temperature at this leg will be -4.
The sixth column is column of speed. Thus, for the first part of a flight, we know from the table of calculations of climb performance it will be 74 knots. Yes. For calculation of task for next part of a flight, we can find in flight manual this table. According to this table, at the height of 4,000 feet, at 75% power, the true speed will be 116 knots, and nautical miles per gallon will be 14. For the height 2,000 feet, at 75% power, the speed will be 114 knots. So there will be also 116, and at the altitude 2000 it will be 114 knots. Calculation CAS, we can calculate EAS by ESXB. It will be 112 knots. So CAS, according to the next table in the flight manual, will be 110. We need CAS for some calculations future. The next column is column of true course. It is the same as the course on the map, and also we have a variation. Variation at our case in our map will be 0 degrees, 0 degrees, 0 degrees, 0 degrees. 1 minute. Because this magnetic course will be the same. Next column is wind correction angle. We can calculate wind correction angle by ESXB, as I shown at my previous video. I will left link in the description of this video. You can see at the screen the calculation on wind correction angle in our case. So we can see that at the first leg wind correction angle will be -4, because this magnetic heading will be 246. Also we can see at the screen calculated ground speed. Also at first leg it will be 64. For second leg, wind correction angle will be -1. Magnetic heading will be 249, and ground speed will be 105. At the third leg, wind correction angle will be 0. The magnetic heading will be 230. The ground speed will be 105. And at the fourth leg, wind correction angle will be -1. The magnetic heading will be 229, and the ground speed will be 103. In the next column, we should write deviation and compass heading. Deviation table should be at every aircraft and calculated during aircraft maintenance. It depends on the course of aircraft. You can see example of deviation table in the screen now. For our courses with our table, the deviation will be 0 at all legs. Compass heading will be equal to magnetic heading. Next column is column of distance. Let's return to the map. At different maps, we have different scales of maps. In this case, we have 1 to 500,000. It means that in 1 centimeter in the map we have 500,000 centimeters. It does mean that in 1 centimeters we have 5 kilometers of real distance. First leg we counted before. It will be 7 nautical miles. Let's draw it in the map. It will be 2.5 centimeters. Yes, okay, 2.5 centimeters. It will be our top of climb. Yes. Second leg, let's measure at the map. It will be 7.9 centimeters. It will be 39.5 kilometers. It will be 21.7 nautical miles. The fourth leg, we know that 9.8 miles. It will be at the map 3.6 centimeters. Top of descent. Okay. And our third leg will be 5.1 centimeter. At the map, it will be 25.5 kilometers, and in nautical miles it will be 14 nautical miles. Total distance will be 7 plus 21.7 plus 14 plus 9.8 nautical miles. In total it will be 52.5 nautical miles. 52.5 minus 7 will be 45.5 nautical miles. 45.5 minus 21.7 will be 23.8 nautical miles. 23.8 minus 14 will be 9.8 nautical miles. And 9.8 minus 9.8 will be 0 nautical miles. The next column is column of time. Let's imagine that our flight will start at 12 UTC. So, at first leg our distance is 13 miles. At table of climb performance as we counted before, we know that without counting effect of wind, the time for first leg will be 5 minutes 30 seconds. However, our estimate ground speed is less than thus for 14% because strong headwind. So let's add for our time also 14%, and our time for first leg will be 6 minutes 30 seconds. At the second leg distance is 21.7 miles. Ground speed is 105 knots. So the calculation for time of this leg is next. 21.7 miles divided for 105 knots and multiple for 60. And our time for second leg will be 12 minutes. For the next legs, the calculation is the same. So the third leg will be 14 nautical miles divided on 105 knots and multiple for 60. It will be 8 minutes. The fourth leg will be 9.8 nautical miles divided on 103 knots and multiple for 60. It will be 6 minutes. Total flight time will be 32 minutes 30 seconds. The last column of NAVLOG will be fuel per leg and fuel flow for a road. At first leg, according to the table of climb performance, the fuel per leg will be 2.7 gallon. However, in our case we have headwind, and I will add 0.2 gallons. So, estimated fuel for first leg will be 2.9 gallons. At the next leg, using the table from flight manual, we can calculate that fuel for this leg will be 1.555 gallon. However, because headwind, ground speed is less than thus at 10%, so I will add 10% of fuel for this leg. So the estimated fuel for second leg will be 1.7 gallon. At the third leg, according to the table from flight manual, The fuel for lag will be 1 gallon. However, because headwind, I will add 10% and estimated fuel for third leg will be 1.1 gallon. According to the table from flight manual, we can calculate fuel per 4 leg. It will be 0.7 gallon. Also, I will add 0.1 gallon because headwind, so the estimated fuel for 4 leg will be 0.8 gallon. Total estimated fuel per flight will be 6.5 gallon. The estimated fuel flow per flight will be 6.5 gallon divided on 32.5 minutes multiplied for 60. It will be 12 gallon per hour. As we can see from flight manual of aircraft, the usable fuel for our aircraft is 38 gallons. So, after the first leg in tanks of aircraft, we left 35.1 gallon. After second leg in tanks of our aircraft, we left 33.4 gallons. After third leg in tanks, we left 32.3 gallons. And after fourth leg in our tanks, we left 31.5 gallon. All other graphs we will not using.
Thank you for your attention. Goodbye.